All right, we're going to try to find the name of these compounds. All right, so that first one is a, all right, there's 6 carbons. Here, let me just number the carbons. 1, 2, 3, 4, 5, 6. All right, it's in a circle, therefore, it's a cyclohexane, right? When we throw in this one double bond, right? Put in one double bond, we still have 6 carbons. We're going to call it cyclohexene, right? With 2 double bonds, cyclohexa-1,3-diene, right? Alternatively, you could call that a 1,3 dash cyclohexadiene. And notice that the A comes in, it's hexadiene, not hexdiene. Okay, come on in. All right, so then let's take a look at these ones right here. Let's try to name these compounds right here. So the last one, again, was the last one we finished with. So again, here, I'll just name this one right here. Sorry, structure. Again, so cyclohexa-1,3-diene. Right? And then I'll give you just a second to draw and name this one right here. Okay, and so if we were using our rules, we would number our carbons, right? So 1, 2, 3, 4, 5, 6. It looks like there is a double bond between the 1 and the 2 carbon, between the 3 and the 4 carbon, and between the 5 and the 6 carbon. All right, so there's double bonds between at the 1, 3, and 5 positions. Here, let's just get rid of those for clarity. All right, so double bonds at the 1, 3, and 5 position. And so 3 double bonds, we would normally call that a, all right, so you would think that this is called 1, 3, 5, cyclo, hexa, triene. And that would be the normal IUPAC rules for naming that particular compound. However, this compound is so common, it actually gets its own name. So when right, so it's not wrong to call this 1,3,5 cyclohexatriene. However, it's so common, it gets its own name, and that name is benzene. Okay, and so any compound, now compounds containing benzene are called aromatic. Okay, and there's many different ways you can depict benzene. Right, and so benzene is this cyclic structure. It's C6, H6, with 3 alternating double bonds. Okay, so benzene. Perhaps now let's get our molecular model kits and just build benzene. Right, just to see what it looks like too. All right, and so you've got the molecular model kit and you've built it. Another way to do this is, not there, but in something called mole view. Okay. So I will, here, I'll put a link to that on our classroom. smell benzene in mole view. All right, so mole view always has this default, when you open it up, it actually has this default compound. And this default compound is caffeine. Right, so that's the caffeine molecule. I'll just erase that. And so benzene's right here, right? So benzene actually has its own little button. I can just click it there. A lot of organic compounds just don't put the hydrogens on. So here we'll just view the hydrogens. And if I want to do this right here. All right, and so one of the things I wanted to emphasize is that benzene sort of has this flat structure, right? And we'll you know, when we do chapter 4, we do bonding. We're going to kind of take a look at that bond angle. That'll be important and what it, you know, what it looks like. But I think just building that structure with its alternating double bonds is important. And so the other way to look at this, and let's see if toggle, right? So sometimes benzene is shown just like this, right, without any hydrogens at all. This is the skeletal formula. And also, sometimes benzene is also shown here, and I'll just options. And so yeah, so sometimes it's shown just like that. Control Z. And then also sometimes it's shown just like that. Right, so just a hexagon with a circle in it. And really that's because those 3 double bonds will tend to actually move around, and they'll tend to do something called delocalize. Right, so benzene can often be written just as a hexagon with a circle in it. And so you'll see all of those various depictions of benzene, right? So you'll see it like this, right? We'll see it just as a hexagon with a circle, or yeah, or just as a hexagon with 3 dashed lines alternating. Okay, so all 3 of those are acceptable. So then, all right, so then if you have a methyl group on a benzene, right, so a methyl group on a benzene, then its name becomes just methyl benzene. Okay. And again, this one's really common, and it's often called just toluene. We'll use the IUPAC name, which is methyl benzene. And again, so one group on a benzene ring, methyl benzene. 2 groups on a benzene ring. Right, and then we're going to have to name number where they are. Right, and we're going to keep our numbers as low as possible. Right, so my 2 methyl groups on this benzene. Right, so let me number these first. Right, so 1, 2, 3, 4, 5, 6. So that becomes a 1,3, right? 1,3 dimethylbenzene. 1, comma 3 dash dimethyl benzene. All right, let's do a couple more of these compounds. Control V. All right, so if I have a benzene group, yeah, this is skeleton here. I'll just change this in a sec. Clean it up. So these are called skeleton structures that really don't have any C's or H's listed. I will change it to my own style. There we go. Okay, so what are we going to call this one right here? Right, we'll want to number it such that the numbers stay as low as possible. Right, so often I'll name those clockwise just by convention, but again, you do not have to go clockwise or counterclockwise by convention. You should number them to keep the numbers as low as possible. So therefore, we'll number these like this: 1, 2, 3, 4, 5, 6. So then that becomes a 1, 2, 1, 2, 4 trimethyl benzene. Okay, let's look at this structure and see if we can name the following structure. Tricky. All right, so I'm going to propose that we can give this 2 different names. So first of all, we could think of this as a benzene group, right, or sorry, a benzene parent chain with this 4-carbon group attached to it. Right, and this 4-carbon group is one of our special groups. Right, it's one of our special groups. So then, right, so I have a benzene ring with a special butyl group off it. And so this butyl group is attached to the 2nd carbon, so that's secondary butyl. Right, so that's S butyl benzene. Right? So S-butyl benzene or secondary butyl benzene. Let's see. What do I mean by secondary? Okay, so alternatively, we can do this. We can consider benzene as a functional group. One, 2, 3, 4. And so benzene as a group, right? So as a group off the main chain of butane. Right, so either of these are acceptable. The IUPAC actually prefers something else, but that's okay. Our textbook uses this system, and sometimes benzene as a group is called a phenyl group. Right, so 2-phenyl butane. All right, so either of these are acceptable. 4. Okay, so 2, right? So we can call this S-butyl benzene, or we can call it 2-phenyl butane, where phenyl, right? So that's a new word. Put that in our vocabulary. Okay, so phenyl is benzene as a side chain. Okay, so benzene as a side chain can be called phenyl. So that compound right there can be called S-butylbenzene or 2-phenylbutane. All right, and so let's do, need some time to write that down. All right, here's another compound. And so once we get to, once we even get to compounds where, so 1, 2, 3, 4, 5. Now we didn't even look at what a 5-chain compound would be called. All right, so then we will just call this, right, we'll consider the 5 carbon as the longest chain. Right, 1, 2, 3, 4, 5. And then we will consider this benzene group. Right, so benzene as a functional group is phenyl. Let me just write that down. So benzene as, side chain. Phenyl, which is different than phenyl, F-E-N-N-E-L, right? Right, so benzene as a side chain is called phenyl. So therefore, the name of this would become 3-phenyl pentane. Okay, so 3-phenyl pentane. Okay, let's go over to the note now. So we're going to follow along the note and also the handout that was given to you. We're going to look at those compounds. All right, so just considering the note right now where it's beginning at naming aromatic hydrocarbons. Right, so if an alkyl group, like alkyl being methyl, propyl, ethyl, etc., to a benzene ring, the compound is an alkyl benzene. Right? Alternatively, the benzene can be considered a branch of the larger molecule. In this case, the benzene ring is called a phenyl group. Right? So we can, both are fine. Right? And again, we want to use the lowest numbers possible. Okay, so now we've seen this one already, and let's. I'm just going to get my pens. Okay, so we have right here. That's all right. So this a very common way to depict a benzene is just this hexagon with a circle. Okay, and there's a methyl group. So again, I'm just going to call this methyl benzene. Okay, so the benzene is that group right there. The methyl group is there. And we don't need a number because there's only one. And it's a circle. And also the common name of this is so common it gets its own name. It's toluene, which is a precursor to TNT. If you make that at home, it's called homemade dynamite. By Lord. Right? Lord? Anyone? Yeah. Okay. Okay, this one right here. So now we have 1, 2, 3, 4, 5. So we didn't even look at branches that have 5 that are not, right? So it's pentyl. Is it an isopentyl, secondary pentyl? Maybe it's an S-pentyl. But we're not going to use those special names for pentyls. We only looked at special names for butyls. So therefore, we will just use our numbering of 1, 2, 3, 4, 5. And this now becomes our main chain. Right? So this are our parent chain. And then the benzene molecule itself becomes our side chain. Okay? And so as a side chain, a benzene becomes phenyl. So I'm going to call this 3-phenyl pentane. Okay? So as soon as you get a 5-carbon or greater, then benzene will become phenyl. Right? And you could have a 1-phenyl, 2-phenyl, 3-phenyl pentane. You couldn't have a 4-phenyl because then it would become 2-phenyl. Okay, so then notice that in these two examples, the phenyl, my pentane is my parent chain, which I've been using yellow highlighter for, and then my group, my 3-phenyl pentane. Right, so benzene as a side chain is a phenyl. Let me write that down. Okay, now numbers 12, 13, and 14. We'll look at these all together. And notice the similarities between them. All right, so looking at 12, 13, and 14 all together. So in all cases, we have a benzene, benzene, and benzene, right? In the case of 12, 13, and 14, we have ethyl groups, ethyl groups, ethyl groups, right? So it looks like a diethyl benzene. And it's a little small to put my numbers on, but you can imagine the numbers. Right, so this is going to be a 1,2, right? So 1,2 diethyl benzene. Okay, number 13 is a 1,3 diethyl benzene. And number 14 is a 1,4 diethylbenzene. And the reason I grouped these all together is because there's also another name for organic compounds that are on benzenes that are in the 1,2 position, the 1,3, and the 1,4. Right? And they are called ortho, meta, and para. Ortho, meta, and para. So alternatively, this could also be called ortho diethylbenzene. Para diethylbenzene. And Meta, formerly known as Facebook. Methylbenzene, all one word. Okay. Or just O. Or just P. Or just M. Okay, so ortho meta para. Yeah, I got my paras and metas mixed up. Right. Ortho, meta, para. I apologize. Okay, so ortho, meta, para. 'And we're going to use that anytime there's two groups that are the same, that are in the 1,2 position, the 1,3 position, or the 1,4 position. All right, so naming number 15. 15 can have two names, similar ones we did in Chem Sketch. All right, so we consider this either, right, parent chain, right? So if that's the parent chain and there's a phenyl group on the parent chain, then I would use 2 phenylbutane. Right, so 2 phenylbutane, or S-butyl benzene, or S-butyl benzene. Right, so we can look at that either way. We looked at that one already. Okay, 16 is I'm given the name and I want to draw it out. So I have a 1-ethyl, 3-methyl benzene. Right, so my strategy is to draw the parent chain first. Right, so benzene, and so the simplest way to do benzene is to just draw the hexagon with a circle in it, and that's always going to be acceptable. Right, you don't have to draw all the carbons and all the double bonds. Just a hexagon with a circle is benzene. And then, and you can pick any of these carbons. I'll just pick this one. This one will have the ethyl group. Right, so it's a 2-carbon group on the 1 carbon. And then on the 3 carbon, so then I have to, if this is 1, 2, 3, we'll have a methyl group. Okay, so there I've drawn 1 ethyl, 3 methyl benzene. So given the name, draw the compound. Okay, 17 is reasonable, and 18 is kind of a challenge question more than anything else. Probably beyond the scope of a test, I think. Maybe a bonus mark on a test. Let's do 17 first, right? So 17, again, we have our benzene ring, and we have 3 alkyl groups, right? Looks like we have a right, looks like there's a ethyl group, and then 2 methyl groups. And then we also have our parent chain here. So from a numbering point of view, we want to number these to keep the numbers as low as possible. And we can also, we can match up our, so this has to be 1, the only way we can do this is 1, 2, 3, 4, right? So if I went 1, 2, 3, 4, then 3 and 4 is higher than 1, 2, right? So I'm going to go this 1, 2, 3, 4, 5, 6. So that becomes a 1 ethyl, and we're also following our alphabet rule here, 2 ethyl before methyl. Then dash 2, 4 dash dimethyl benzene. Okay, so my benzene is the parent chain. My 2 methyl groups are on the 2 and 4 carbon. And then my ethyl group is on the 1 carbon. I'll give 18 as a challenge to you, but I'll give you a hint, and this is the hint. This has to be the parent chain because it has a double bond. Okay, so I'll leave 18 as a challenge, and then also there is some homework to do right there. Page 21, 7 and 8, 23, 1 and 4. Stop. Oh no.